My name is Justin Bullock, and this is our ME106 project. What we have here is a hot box. Essentially, the function of this device is to create a controlled environment that captures heat, creates its own heat source, and provides a constant temperature for doing experiments, or in our application that we thought of, making bread from yeast, so letting it rise in a constant temperature. So what we were able to do was repurpose a old towel warmer from my mom's hair salon that was broken. We stripped out all of the inside components and all of the electronics from the back, and we started out with mounting our two heaters here. I believe they're 12 volt 200 watt resistance heaters. Because of this, the heaters do not create any convection actually of the heat throughout the box. So in order to facilitate this, we actually had to go and mount vents and fans along the side. So this is where the electronics portions start to really mesh with the mechanical aspect of this. So after creating and fabricating some vent holes on both the right side and the left side here, we mounted a fan on the right side and a servo with a opening and closing 3D printed vent that allows the heat to be sucked in and fresh air to be drawn in and the heat to be blown out of this box. So on the left side here is where we start to see more again of the electronics meshing with the mechanical portion. Ankish Priet, my partner, will go into further detail of all of the electronics in the back, because he did a really great job in really connecting them all and making it work really smoothly together with what we have here. And just to wrap up with this vent, the servo and the potentiometer controls kind of the opening and closing if you wanted some more manual control, but again, Ankish will go into further detail with that. And
my name is Ankish Priet, and I will talk about the actual design specifications for all the electronic components and how we wired all of the subcomponents to it. Inside, we have three temperatures, LM35 sensors to gauge the temperature that's converted to Fahrenheit. We chose three because we wanted to get a good average around the entire box itself without having to risk any errors. On the back of here, our biggest problem was to power the heaters themselves because they required a lot of amperage. Our best solution was actually to reuse an old PSU from a computer here, wired it specifically so that it turns on just by the source of clicking the button here. We have three 12 volt power outputs here, and as well as a couple of 5 volt outputs to power any auxiliary devices and the Arduino. The 12 volts are specifically used for the heaters themselves. They're both rated at 100 watts each, so they each require 8.3 amps to be turned on, have enough to actually heat them up to whatever they need to heat it up to. As I was mentioning earlier, the 12 volts are connected to the heater, which are sourced down here. We understood the importance of actually having a display so that anyone that was using it can actually understand what's happening inside the environment. So on top, we have wired a LCD panel with 6 different analog buttons. These analog buttons are read by the analog input of the Arduino and can tell whatever functions, presets they need to do, such as increase the fan temperatures, increase the temperature specified to whatever the ambient conditions need to be inside. As far as the servo control works, we have this directly connected to the potentiometer, and this dictates how much the vents open or close based off just the analog inputs going directly to Arduino. We used a map function to facilitate a full rotation equals just whatever increment rotation this requires to fully open, fully close. For the fans, the CPU fan is a 12 volt 0.18 amp operating CPU fan used to control internals of a computer. We wired this to a MOSFET, which is located right here. And this is actually being controlled by how open or closed the potentiometer is going to be, where this switch is, and how much fan is open. So more the fan is open, the more airflow is going to be directed out of the box itself. So once it's closed, there's no CPU fan that's being turned on. That way it heats up to its whatever set temperature it heats up to. This is a demonstration video of the hotbox. Before I begin, I'm going to open the device, place in this piece of candle wax. This is on top of a plate, on top of one of the resistive heaters that we have inside. I'm going to turn on the device, which is over here. As the temperatures continue to increase inside, I'm going to open this guy up real quick. So far, about a minute has passed, and you can see the candle wax already slightly melted. This shows that the resistive heaters are working. I'm going to place that there. And that is the demonstration of this project.